Hello everyone. Welcome to Texas Instruments Innovation Challenge India Design Contest 2015. Our project is Medicine Identifier for Elderly and Visually Challenged People. We are from Sri Vishnu Engineering College for Women Bhimavaram. We are 6 in team and our team ID is 2047. We have done this project under Assistive Technology Lab, Sri Vishnu Engineering College for Women. Our mentor is Dr. K. Padmavasvi. India, being second largest populated country, consists of 15 million visually impaired people. There are 8% of elder people in 2007. To our surprise, there would be a drastic improvement up to 19% in the mid-century. Due to the old age, the immunity power of human would be decreased. To overcome this, we use lot of medicines to regain energy. Elderly people may not remember each medicine and time to take, so they have to depend on others to make them healthy. Visually challenged people identify medicines by their shape, size, and order. There would be an ambiguity to take new medicines. They should be trained about the shape and size every time they take a new medicine. There is an ambiguity in selection of medicine. So how to identify a medicine? The existing solutions are: earlier we used a braille readers in which waterproof markers are used to mark both bottom and top of the medicine bottles with first initial of the medicine for identification. They used a sticky clear tape called Dymo tape to create custom braille labels. Another existing solution is talking prescription readers, manufactured by the Millennium Compliance Corporation, which are available through NFB independent market. These are reusable readers attached to the bottom of the most standard sized pill bottles. The device allows the user or pharmacist to record up to a minute of instruction and precautions on the digital recording chip in any language. However, this device is not still available in Indian market.
In order to overcome above problems, we came up with a prototype medicine identifier for elderly and visually challenged people. Component required. The main component required in our project are Launchpad. Here we have used MSP EXP430G2 as a launchpad. It provides an easy solution for programming and debugging of MSP430G2 series type microcontrollers. This launchpad contains red and green LEDs for providing visual feedback. This launchpad are available in market either 20 or 14 pin packages. The next one is microcontroller. Here we have used MSP430G2 It is an ultra low power IC. IR sensor. An IR sensor is an electronic instrument. It is used to sense certain characteristics of surroundings by either emitting or detecting the IR radiation. For detecting IR radiation, sources like blackbody radiators, tungsten lamps are used. The next one is push button. It is used as input for voice module. The next one is voice module. Here we have used APR9600. This is a voice pre-recorded chip. Audio amplifier. Here we have used LM384 as a audio amplifier. This is used to amplify low power audio signal to certain level that is suitable for loudspeaker. Voltage regulator. Here the voltage regulator is LM317. Here we give the 5 volts as a input. Then it is regulated to 3.3 volts. These 3.3 volts are enough for our microcontroller MSP430G2
This is our block diagram. It consists of IR sensors, microcontroller, voice chip, audio amplifier, voltage regulator. The inputs are taken from IR sensors. IR sensor has 3 pins, VCC, ground, output. The output of each IR sensor is connected to inputs of microcontroller MSP430G2 It is a ultra low power IC. It needs 3.3 volts. For that requirement, we have used LM317 voltage regulator. It regulates the voltage up to 3.3 volts. The output of microcontroller is given to voice module APR9600. It has a facility of voice record and playback. So we record the name of the medicine and the purpose of that medicine. But voice module produce low power output signals. This voice may not be heard by the elderly people because of their less hearing capability. To amplify those voices, we are using audio amplifier LM384. It amplifies the signal which is suited for loudspeaker. This is our breadboard implementation. We implemented our circuit in TINA software.
This is the overview of our prototype. Our prototype has 7 compartments to place medicines for elderly and visually challenged people. This is made rigid in order to keep it in a fixed place, because if it is easy to carry, they may place it somewhere and there is a chance of forgetting where they have placed. In order to identify the medicines and their purposes, IR sensors and push buttons are arranged. Since we have used ultra low power microcontroller, instead of using sensors in all compartments, 3 compartments are equipped with IR sensors and 4 are equipped with push buttons.
We have done testing in analog discovery kit by using virtual LEDs. In this, we have used 6 switches and 6 LEDs for testing. When the lid is opened, the IR sensor in the compartment is activated, the corresponding output is spelled out. In the shown figure, the first switch is off, the corresponding LED is off. The output is activated and spelled out. The same way, it is applied to the remaining compartments.
Coming to the working of our project, these 3 are equipped with IR sensors and remaining 4 compartments are equipped with push buttons. In case of IR sensor, when the lid is opened, the corresponding pin of microcontroller will be high. Then the voice chip spells out the name of the medicine and its purpose.
Demestral, Vantilaku.
In case of push buttons, since the push button is directly connected to the voice chip, when they depress the button, corresponding voice will be spelled out.
Afternoon medicine. Afternoon medicine.
In this way, it will be helpful for elderly and visually challenged people.
By this, the chance of taking help of others is reduced by elderly and visually challenged people by using the medicine identifier. This is a power-seeking box which when we increase the number of compartments. So we have limited this to only 7 compartments. This is so helpful for elderly and visually challenged people while taking their medicines